So the idea here is to talk about what we call the bias in behavioral economics, which is the idea that maybe researchers in behavioral economics was biased by looking at bias everywhere. Okay, so we will some kind somehow debunk a bit some biases. Then we'll talk about nudges, which are the consequences of cognitive biases and how we test them in reality. And finally, we talk about the heterogeneity revolution. And the heterogeneity revolution, it's what is happening right now with behavioral economics. So it's very nice for you to know what is happening right now. Okay, so let me make a small statement about you. You see well the screen is okay. Okay, how we can improve it, you know? I think I turned everyone. Okay, okay, it's better, right? Yes, yes. So a small statement about the history part. So the study of behaviors from economics began just after the World War II. What's interesting here is that most researchers found out that people are rational. Okay, and it led to a theorization of one program called the intuitive statistician program. The intuitive statistician program is the idea that people have in their mind an intuition of statistics. Even babies, they have the intuition that they have probabilities inside their heads. Okay. In a review in 2067 of more than 160 experiments, psychologists Cameron Peterson and Leroy Beach conclude that people can make reasonably accurate inferences about probabilities. People, the researchers argued, are intuitive statisticians. So at this moment, it was like the common knowledge that people are good statisticians. And then in the 70s, Kahneman and Tversky, with the heuristics and bias program, they postulated that people are irrational with cognitive limitations. So we have some kind of contradiction, a paradox here. The question is how we can resolve this paradox. And we can resolve this paradox by taking into account that experimental methods are not neutral tools. And I will explain to you what it means. Okay? Experimental methods are not neutral tools. I will share with you a figure from this study called How Experimental Methods Shaped Views on Human Competency and Rationality. What they did here is that they looked at the citations of studies from the two programs, the intuitive statistician program and the heuristic and bias program, and they compared how it varies by years. And I will show you the result here. So let's say we take the study of statistical reasoning here. We see that the idea that humans are intuitive statisticians, the citation rate is very low. But for the heuristic and bias program, the citation rate goes exponentially. So there is huge preferences by researchers for the heuristic and bias program. Here, if we take the Bayesian reasoning, which is another case of being rational or irrational, are we thinking Bayesianly or not? We have here conservative Bayesian saying that people use Bayesian modeling in their decision-making, which is never cited. And then the non-Bayesian at all from Kahneman and Tversky also increased. So researchers, no matter the domain they want to study, they prefer the heuristic and bias program to the intuitive statistician program. Okay, the question is, no, we have two questions. The first one is what is the exact difference between the two programs? And the second question is why they prefer the heuristic and bias program. So there are two differences. The first difference is concerns learning and feedback. In the intuitive statistician program in the 60s, researchers used an experiential protocol that allowed people to learn probabilities from direct experience. Usually, people could practice sample information sequentially and adjust response continually with feedback. What it means, it just means that we ask people to make a trial they make a judgment, they make a choice around this trial. Then we tell them you failed, or you succeed, or you earn a bit of money, or you earn a lot of money. Then you can play again. And they play and they play and they play. And at the end, we see that they are rational. Okay. But with Tversky and Kahneman's experiments, they replaced it with a descriptive protocol. Their experiments presented people with descriptive scenarios and word problems and tended to ask for a one-off estimate or judgment. Participants in their studies had little opportunity to practice or learn from feedback. So basically, in Kahneman and Tversky experiments, they say, okay, John did something and had this outcome. Paul did something and had this outcome. Who you prefer? Which character do you prefer? Which one is the most upset? Which one has the most anger? Which one has the most sadness, etc., etc. So you just have one-shot description, you choose, and then you leave the experiments. So you don't have the possibility to train, and you don't have the possibility to have feedback. And in this situation, with this kind of scenarios, you are irrational, basically. Okay. Second difference is the possibility to put these scenarios into reality. A researcher called Simon urged economists to move away from as-if expected utility models and study how people actually make decisions in realistic situations of uncertainty as opposed to under risk. So basically, he said, researchers who are looking at cognitive biases, if you can just stop people play dice or play with a coin or play and just study how they make decisions in reality, how they decide to buy a house, how they decide to buy a car, etc., it would be more useful because we will have a better description of the reality people are doing in the reality. And this case resonates heavily with Kahneman and Tversky's experiments. I will show you one example from Bayesian reasoning. This example comes from Kahneman and Tversky's experiments. They say a disease has a base rate of 0.1 and a test is performed that has a hit rate of 0.9 and a false positive rate of 0.1, the conditional probability of a positive test given no disease. What is the probability that a random person with a positive test result actually has a disease? It's very difficult. It's a very difficult problem. And we need to use Bayesian equations to understand this problem, and it's very difficult. Now, two researchers, Ertwig, and I don't remember the name of the second one, they proposed this. Hello. It's the Behavioral Economics seminar here. Right. You can come. They propose a second scenario, this one. They say among every 100 people, 10 are expected to have a disease. Among those 10, 9 are expected to correctly test positive. So there are 10 people that are positive. And among the 90 people without the disease, 9 are expected to falsely test positive. What proportion of those who test positive actually have the disease? So it's 9 divided by 9 plus 9. Okay? And so basically, this is exactly the same output, the same result. But here, you need the Bayesian modeling. And here you just look at the text and it's quite easy for you to make a judgment. So we have two different scenarios. One is easy to understand. The other one is not that easy to understand, but the procedure is exactly the same here. They ask 160 gynecologists about their answers. And for the first scenario, 21% guessed right. So there is a cognitive bias, meaning that people do not understand correctly this scenario. What is this bias? Kahneman and Tversky says, this bias is called the base rate neglect. You can come. Base rate neglect is that people fail to take into account that a disease has a base rate of 0.1. Okay. Here, 87% of the people guessed right, meaning that they are not biased. Most of them are well calibrated. And the researcher says there is a debiasing effect. Human can learn Bayesian inference quickly if the information is presented in natural frequencies. Basically, what they are saying, what they are saying is that it's very easy to make the correct statements and to have the correct information if it is presented in the easiest way. So it's the debiasing effect. Now, the question is, why is the heuristic unbiased program so popular amongst economics? One reason is that there is a minimal setup and implementation cost leading to cheaper data collection. As I told you before, if you want to make trials, you will have to pay the participant for each trial. So in the end, the participant will receive 10 euros, 20 euros. It could be very expensive. If you make just one description, so you say, we have, for example, this description here, you just tell them what is the correct answer. Then they just say the correct answer and they get money if they are right and they don't have money if they are wrong, and that's all. And so it takes far less time and it's far less expensive for the researchers. Second is that there is a tendency for researchers to like this series. If we say human beings are rational, they are intuitive statisticians, okay, that's nice, but we cannot say much about that. If we say people are irrational, then you can say, okay, I think better than you because I understand better how people work, how people's mind work than you. So then I can study irrationality and it's more appealing. And finally, there was a possibility for researchers to advance their career because the intuitive statistician program in the 70s, it has been 30 years that it was in place. So we studied mostly everything we could about that. So then when another program opened up, so the heuristic and bias program, it was the researchers had the possibility to went through and publish a lot of papers out of that. So it was a possibility for them to advance their career. And finally, they had a demand from policymakers, meaning that if we have cognitive biases, it means that the governments might change the behaviors of citizens by using behavioral economics. So there was a potential here. So the policymakers were really interested in that. And so it led to a bias of bias, the idea that we put a lot of emphasis of cognitive biases compared to their real potential to explain how people's mind work. So this is the paper we will review today called The Bias in Behavioral Economics by Gerd Gegenreisen. So it's a big article, but the main points are the following. He said, behavioral economics, when they say that people have a cognitive bias, they say that to have a cognitive bias, we need the following arguments. The first one is a lack of rationality, meaning that all of the experiments from the heuristic and bias programs show that people's intuitions are systematically biased. Okay. Secondly, stubbornness, like visual illusions. And if you have read the book of Kahneman's Thinking Fast and Slow, he refers a lot about visual illusions to talk about illusions in judgments. Biases are persistent and hardly corrigible by education. Even though we know that we are biased, for the next decision we have to make, we will also be biased. Okay, so this is the idea of stubbornness. There are substantial costs. So biases may incur substantial welfare-relevant costs such as lower wealth, health, or happiness. Some researchers said that it's because we are biased that we smoke, or it is because we are biased that we buy stuff we don't need, etc., etc. So it leads to substantial costs. And finally, because it leads to substantial costs, biases justify governmental paternalism, which is the idea that to protect people from their biases, the governments should nudge the public toward better behavior. Okay, so basically we will review these four arguments and explain why they are wrong. Okay, so for the lack of rationality, one argument against the lack of rationality is the one we just made before, which is the idea that if we frame differently, if we modify the information for the scenario, then the bias in the first scenario completely disappears in the second scenario. So this Bayes rate neglect only comes from the scenario, the description of the scenario here. I can show you another example. This example comes from Liechtenstein in 1878. So it's about the representativeness heuristic. They ask US participants to tell them what are their estimated number of deaths per disease or per I think they are all kind of disease or accidents. So basically what they say is that, so here we have the actual number of deaths per year, and here we have the estimated by the participants. So if people were rational, they would be well calibrated, and so they will follow this line here. Okay, so 10 would be 10, and 100 would be 11, etc. Would be 100, etc. Now what we see is that people, they think that botulism kills far more people than it actually kills. Okay, so they overestimate. And here they think that stomach cancer kills far less people than it actually kills. Okay, so they underestimate the risks. Okay, so what it is called Liechtenstein, but also it comes from Kahneman and Tversky's representativeness heuristic, says is that people use what is easily available in their minds, easily accessible in their memory, to estimate frequencies. Okay, to estimate the number of deaths. But then Hertwig in 2005, he asked the exact same question, but instead of asking the participants what are the estimated number of deaths, he asked them the estimated percentage of deaths. Okay, and then we transform so that we can compare the two graphs. We transform the graph of percentage of frequency to a one of estimated number of deaths, just to show you. So this is the graph, and what we see here is that here we still have the rational, well-calibrated line, and what we see here is that people, they underestimate the frequencies, and here they overestimate the frequencies. So here they overestimate, then underestimate, and here they underestimate, then overestimate, just by changing the question. Here is actual number, and here is frequency. Okay. But then what Hertwig said is that if we look at the distribution here and here and here, the distribution is higher here than here than here. Meaning that here people knows better how to be calibrated, so they are more rational here than here and here. And here they are not, because they don't have much information. Botulism, for example, is we have the tendency to think it's very dangerous, but we never have seen someone with botulism, so we don't really know how dangerous it is. So we just estimate with too few information. And so this indicates that this effect comes from what we call a regression to the mean. So it's a statistical artifact. It's not a cognitive bias. It's just an artifact based on the question we ask and the way we ask the questions. Okay. Another example. Sorry, this should not be displayed right now. This is very famous example, this one. There is an impending pandemic threatening to kill 600 people, and you have two options: A, save 200 people, and B, save 600 people with 1/3 chance and save 0 people with 2/3 chance. And we ask participants, do you prefer the plan A or the plan B? Then to another group, we ask, the same disease is threatening society, but you are given two different options this time: kill 400 people or kill 0 people with 1/3 chance and kill 600 people with 2/3 chance. These are equivalent. So if we are rational, we should decide between the certainty. If we are someone that likes certainty, we would choose A and C. And if we are someone who are more risky person, we should prefer B and D. Okay, so it would be rational. However, most people prefer A and prefer D. So there is a lack of rationality, and Kahneman and Tversky explain that it is because of a frame. Here we are in a frame of gain, we save, and here we are in a frame of kill, so a frame of loss. Okay, and they say in loss we are averse, so we prefer to gamble more, and in save we are no, sorry, in loss we prefer to gamble, and in save we prefer to be certain. However, if we look at this scenario, they are not equivalent in terms of information. because we need to have the full information for the A and the C. For the A, we say we saved 200 people, but we don't know if we can save more. So we should say we save 200 people and we do not save 400 people to be equivalent with B, because B we have the information for the save and for the kill. Okay. And the same for C, we should say kill 400 people and not kill 200 people or save 200 people. It depends on how you want to frame it. And the thing is, in 2014, a team of researchers tested it with the full information, and then there were no differences. The people who choose A choose C, and the people who choose B choose D. So there were no cognitive biases. If we have the whole information, this is what is said here. We need the full information for both programs. Okay. Another example, so we debunk a bit all of the scenarios made by Kahneman and Tversky, and another one. So you remember maybe the conjunction bias. This example is Linda is 31 years old, single, outspoken, and very bright. She holds a master's degree in philosophy. As a student, she was very concerned about issues of discrimination and social justice, and she also participated in anti-nuclear demonstration. Do you think Linda is more likely to be a bank teller, active in the feminist movement, or a bank teller and active in the feminist movement? This scenario is really framed as she's a feminist. So most people would say there is huge probability that she is active in the feminist movement. But the thing is, it is so strongly framed that people say that there is huge chance that she is a bank teller and active in the feminist movement more than she is a bank teller. However, it is not possible because she is a bank teller and active in the feminist movement. She has to be a bank teller. So there is a problem of conjunction. She needs to be A and B to be C. However, people say that it's more likely that she's C than to be A. So there is a bias here. There is a problem of rationality. Okay? And it works very well. I mean, this experiment here, you can reproduce it very easily. And then a friend of mine, he tested this experiment, but he tested also an experiment very close to this one with this description. James grew up in a family of gypsies. His father was a musician and his mother a painter. They lived together for 40 years and never married. James was a very talented kid with a special gift for comedy, but he turns into a rebellious troublemaker in his youth. He dropped out of college after 2 years and traveled to Asia to learn the crafts. James is now 35 years old. Do you think James is more likely to be an artist, voting for the Conservative Party, or an artist and Conservative Party voter? Basically here, it is more or less clear that he's an artist. I mean, all of the descriptions lead to think that he's an artist. And then we wanted to know if there were more possibilities that people attribute the more probability to be an artist and voting for the Conservative Party than only voting for the Conservative Party. So we wanted to mirror the first study. And the thing is, so for the Linda profile, we need to look at the difference between the unlikely. So the unlikely is the bank teller and the bank teller plus feminists. And here we have a strong difference. And the difference in means is 9 and here 18. So like it's double. The N is double the unlikely. So people say that there are like too much time the possibility that she is a bank teller and a feminist than only being a bank teller. So it's very huge difference. But now for the James profile, the difference between unlikely voting for the Conservative Party and voting for the Conservative Party and being an artist is very similar, 18 and 15. So just changing the scenario makes the conjunction bias completely disappear. The scenarios are quite similar in their structure, but here there are no conjunction bias. So again, another argument showing you that a lot of different scenarios, when we change a little bit the frame, the bias disappear. Okay. Now, I'm sorry, I forgot to translate the title. So it's entêtement is the French word for stubbornness. Stubbornness. So even if you know they exist, you can't help but see them. This is the idea of visual illusion. So here we have a visual illusion. You know that it is an image because I tell you it is an image. It's not a GIF or whatever, it's just an image, but it moves. Even if you want it to not move, it moves. Okay, so this is the idea of visual illusions. And what Kahneman and Tversky says, oh yeah, like visual illusions, biases are persistent and hardly corrigible by education. And even if they exist, you can't but see them. However, it's very weird to present visual illusions are a good metaphor for cognitive biases because visual illusions are not a sign of irrationality. They are a byproduct of an intelligent brain that makes unconscious inferences from two-dimensional retinal images to a three-dimensional world. So we have eyes who can only see in two dimensions, and then our mind reconstructs a three-dimension image. So it's very intelligent process. And Shepard in 1990, he said to fool a visual system that has a full binocular and fully mobile view of a well-illuminated scene is next to impossible. What it means that we don't have visual illusions in our daily lives. Visual illusions like this one, doesn't exist in our daily lives. They only exist because they were created by magicians or researchers because it's funny to create them, but they don't exist in real life. Okay, and then we have researchers who said cognitive biases are exactly like visual illusions, and they apply to all of our decision making in daily lives. So this metaphor is wrong because this one doesn't exist in real life. And then he said, in psychology, the visual system is seen as more as a genius than a fool in making intelligent inferences, and inferences, after all, are necessary for making sense of images on the retina. Visual illusions is the proof that we are very intelligent. So it's very weird to say that it is a good metaphor to say that we are not and we are irrational. It's completely different. And now I can talk about the substantial costs. So the third argument on the bias. The idea that because we have cognitive biases, it leads us to produce bad decisions for our wealth. We lose money in buying stuff we don't need. For your health, we don't go to sports as often as we should, or we smoke or whatever, etc., etc. And also maybe we make a bad choice when choosing a job or a course or lecture, whatever. And then I will talk about this very nice paper. You can see the number of authors. It's quite huge. And the reason is that they tested cognitive biases across 27 countries with more than 5,000 participants. And the idea is that they tested between low-income people and positive deviants. What are positive deviants? There are individuals that had overcome financial disadvantages as children. So there are people who went from low income and managed to be in the middle class or having better income than what they should have if they follow the path of low income. And the idea is that we will test these participants to see if they have differences in their cognitive bias, in their effect size for the cognitive bias. Maybe these positive deviants, they are less likely to fall into a trap based on cognitive biases, so they make better decisions. Okay? So they did that with a lot of different biases. And as you can see, there are huge differences between biases, so it's not that important. But if you take the difference between the groups, there are no differences for each bias. So everybody, if they're from low income or if they are positive deviants, they make the same kind of decisions. So people are poor. This is the name of the study. People are poor, but not by choice. It's not because they make poor choice that they are poor. Okay, it makes sense. I mean, we know that there are lots of structures that leads people to be poor and others to be rich, and we know that lots of very rich people inherit their wealth from their parents, etc. So, however, it means that there is no substantial cost associated with cognitive biases. Cognitive biases are the same for everyone. It's not something that are stronger with people with low income. Okay, so we went here. we took all the arguments from behavioral economists saying that there is a huge problem with cognitive biases, and it's very nice to study them because we can help people improve their decision making by showing that there is no strong lack of rationality. Cognitive biases probably exist, but the theory cannot be easily applied to all situations, but also in real life situations. It's not that evident that it applies in real life situations. There is no kind of stubbornness here because we have seen the debiasing effects in the first third slide, if I remember, showing that if we change the frame, then the bias disappears. So we can teach people good statistics by by making it easy for them to understand the scenario. Then we have seen that there are not substantial costs. However, maybe that the biases could be used, or theory on biases could be used to justify governmental paternalism, meaning having governments helping people making better decisions. Okay, so we will study that now. Oh, before that, just a small conclusion on these three parts here, because I like this citation. It comes from the APS president, Alison Gopnik, who said, "Why are grown-ups often so stupid about probabilities when even babies and chimps can be so smart?" And it's true, when we study babies, even very small babies, we study how they have probabilities, and we figure out that they're very good at probabilities. And when we study hawks, or we study chimps, or we study animals, we see that lots of different animals have intuitions around probabilities. And then we say, yeah, but adult humans, they don't have they don't know anything about probabilities because they are irrational. So there is a huge discrepancy between this field of research. And the reason is because the experimental methods to study babies and adults are different, and then they lead to different conclusions. And we have to acknowledge that the methods are not neutral, and the results depends on the methods we use. Okay, and then I can share with you the exact definition of the bias, which is the tendency to see systematic biases in behavior, and even when there is only unsystematic error or no verifiable error at all. So the bias is the idea. So it's quite ironic to say that there is a bias to people that people who study cognitive biases area have bias because they study too much cognitive biases. So this is like the bias. Okay, now let's go for the behavioral patternism. Do you have any question for the first part, or is it clear? Okay. Okay. So the behavioral policies with the governmental paternalism. So the idea of governmental paternalism is to protect people from their biases, the government should nudge the public toward a better behavior. So it's the idea of nudges. What we call behavioral policy is the idea of having an economic policy informed by behavioral theory. So we will use the behavioral theory on cognitive biases to inform policymaking. Since behavioral, like neoclassical economists, take their central normative concern to be welfare and perhaps its distribution, this work is often discussed under the heading of behavioral welfare economics. So the idea is what do we want to maximize in terms of economics, and what we want to maximize here is the welfare of the nation. Okay. They call it libertarian paternalism. The idea is that it is legitimate to help people make better decisions themselves by their own lights, if it is possible to do so without interfering with their liberty or autonomy. So if people still keep their liberty, we can still helping them improve their choice. It is libertarian. So libertarian paternalistic is paternalistic in the sense that it aims to make people better off. We know better as a government what would be the best solution. So it is paternalist to tell them maybe this solution is better than the other one. But it is still, so yeah, it aims is to enhance the welfare of the people who are targeted by the policy, but it is also a libertarian in the sense that it tries to do so in a manner that respects the liberty and autonomy. We know better than you what is the best solution. It would be better for you to make this better solution, but you are free to do as you like. Okay. And then we have nudges. So a nudge is an intervention on the choice architecture such that the following criteria are satisfied. It aims to help people make better decisions themselves rather than making decisions for them. It imposes trivial costs on people. It should not be difficult to make the correct choice for them. It should have no effect on people who are already rational and informed. The people who make the correct choice, we should not target them. It should not affect them in any way. And it has a non-trivial and potentially large beneficial effect on people who are already rational or informed. People should go to the better option with the nudge. If they don't go, it means that it is not effective, basically. So a few examples of nudges. The first one is the default option, which is the option that are made default unless the decision maker makes an active choice to opt in or to opt out. So I take the example of social media privacy settings that are often public unless you change them. But let me give you another one, which are the cookies. The cookies, for a long time, when you go to a website, your computer will download the cookies without you any knowing about that. If you don't know what is a cookie, it will just be hidden from you. Now the European Union, they made a law saying that you need to accept the cookies to visit a website. So the default at the beginning is you accept by default. Now the default is you have to click to accept. Okay, so this is a nudge. It's the difference in your choice architecture to accept the cookies. Okay, but you are still free to accept or to refuse the cookies. Okay, so it's still a nudge. Another one is the cooling off periods. So there are periods of time following a decision in which decision makers can reverse their choice to counteract impulsive decisions. So people can be impulsive, they can make bad financial decisions, they can buy stuff they don't need. And the cooling off period is just the idea that if you are not satisfied with the product you bought, you can take it back to the supermarket and be reimbursed. So it lowers the costs associated to impulsiveness. Okay, you are free to use the period or not. So again, it's a nudge because you are free to use it or not. And if you made an informed decision, if you bought something because you knew it was good for you, it will not change anything. So it's a nudge. Another one, so this one is more related to the US system. The Save More Tomorrow program, which encourages workers to save more for retirement by giving them the option of committing in advance to allocating a portion of their future raises towards saving. So they make a salary and they know in the future that their salary will grow because they will grow in uncertainty in their work. So then they can say, okay, I will have more money later, but maybe I can say now that the money that will raise, I will put it in retirement. So I will keep the same salary all over my life, but the increase will go in my retirement. So it's a nudge. You are free to do so or not, but people who are afraid to miss money for their retirements, it will be better for them. Okay. I have another example of nudges that I really like that we don't have in Cyprus because it concerns trains. So in Paris, because I come from Paris, in Paris, we have a lot of trains and we have a lot of crowds, like there are many people who take the train. So we have a problem of timing. The departures are delayed because too many people want to go inside the trains and too many people want to go out of the trains. And so people just crash into each other. It's like, whoa, okay. So what the government did is they draw a line on the floor and the line is drawn between the doors. So people know that they have to wait at the lines because they know that where there are no lines, there will be the doors. So they know that people will go out where there are no lines, and then they will have the possibility to go in. Okay, you understand what I mean? So it helps a lot the eliminating retard from departure. And people are free to go everywhere they want in the train station. So it's not like they force them to be at the lines. It's just helping them to make the better choice so that they can depart faster. Okay. So there are lots of different nudges. Some are more physical. I have another one. For example, if you have an escalator and you have not a scale, but how we can say, I don't remember the word in English. Stairs. You have stairs and you have an escalator near the stairs. Then we want to encourage people to take the stairs instead of the escalator because it's better for their health. Then we can, for example, draw a few words on the stairs, such as 0.2, 0.2 calories, 0.2 calories, 0.2 calories. And then every step you make, you lose 0.2 calories. So it's just like giving you a small information that if you take the stairs, it will be better for your health. Okay, so there are lots of different nudges that are put in place. And if you go outside, you might find some in Cyprus too. Okay, so we have tons of, yeah, sure. Yeah.
But the line, because for it to be a nudge doesn't mean that you can cross the line if you want to. But it's there to help.
Yeah, there will be no one. If there is someone to tell you something, it's not a nudge anymore.
Yeah.
Yeah. Oh, you mean people in France will do that?
I mean, no, if there's a police officer.
No. No. It's not illegal. It just here. It just appear in one day, and people just make a habit of being here. But not that much people follow because Parisian people, they don't really follow the rules. So it's like it helped a bit, but not that much. Okay. But no, if we have someone, a police officer or someone who said you should not cross the line, then it would not be a nudge. Yeah. Okay, we have tons of behavioral insight teams across the world. So as you can see, most of them are in Europe or in the US. But it's a huge field of research. There are many researchers working on nudges. So you might hope that nudges are effective so that we understand why there are so many people working on nudges. But before looking at the effectiveness of nudges, we will talk about the idea behind nudges. And we have to say that nudges are political tools. It is politically oriented. We have this paper from Shatter and Lowenstein, who talks about the I frame and the S frame. I frame means individual frame, and S frame means systemic frame. And they say when we have a problem in a society, we can look at it through two frames, the individual frame or the systematic frame. Okay. And they provide several examples of that. I will take the obesity, but if you take the slides will be available. The YouTube video will be available, and I will put the slide link under in the description. If you look, for example, obesity, in the I-frame interventions, which are the nudges, we can, for example, create a Nutri-Score. The Nutri-Score is a nudge because we don't say to people, you should not buy that or you should not buy that. It's more like this product is probably of less quality than this other product. Okay. There are also the possibility of change the portion size. For example, you want to buy cookies. You can buy the whole box of cookies, or you can buy cookies which are like 4 individual small box with just 4 cookies inside. So you have a few less cookies, and so you might just eat 4 cookies instead of the whole box. Okay, you have more plastic waste. But it would be better to just eat 4 cookies instead of the whole box. Also, possibility to have weight loss incentives. So paying people who lose weight or having incentives for individual to exercise. Telling them if you exercise, you might earn money, etc. So everything is about individuals here. The question we just leave people to choice of buying some kind of food or the other, or to go to sport or the other. It's up to them. But then you can look at it in a systemic frame. And in the systemic frame, we can have tax sugar. The more sugar you put in your product, the more tax you will have. You can also have subsidized for healthy food, meaning that if your food is healthy, we will lower the tax rate. Also, the possibility to pay to subsidize sport training centers so that people, when they want to go to sport, it's cheaper for them. It's systemic. We don't say to people, we will give you money. We say we will give money to the sports center so that the cost to go to the sports center will be lower for everyone. So it's systemic. Okay. So, and you can apply it to all political problems. Okay, so we always have these two ways of thinking. The one is we will give much liberty to everyone and everyone will do as they like, but we can encourage them to have the good position, or we can protect people systematically against bad behaviors. Okay, so there is no like, I will not tell you which is the best or whatever, but we have to acknowledge that nudges is only concerning the iframe interventions, and maybe sometimes some governments, they will rely a lot on iframe intervention, neglecting the systemic interventions. Okay. Now the question is, do nudges work? Because if we have so many behavioral insight teams, if it is that, if it could be used by that many governments, we hope that it should work. Okay. We have one study by De Vigna and Linus called Artists to Scale Comprehensive Evidence from Two Nudge Units. So Elizabeth Linus, she worked in two different behavioral units before working to the academia. And she published this paper based on the results from her two nudge units. And she compared the effect sizes from the academics and from the behavioral units. If we look at the paper published in academics, so the no effect is the zero line here. We can see that there are few studies here with no effects, but we have lots of studies here with a very huge effect. So it's not like a bit of homogeneity where all studies are here or just here, whatever. We have a huge heterogeneity. Lots of studies indicating no effects, and some studies indicating a very huge effect. So there is a problem with academics and papers. One problem, and I will talk about it more later, is this one from Wonsink and Funk. Wonsink is a researcher from Cornell University, I think, who committed fraud. And lots of his research were retracted. This one, I don't know if it was retracted, but if we look at the effect size, we can say it's too good to be true. It's just too high to be believable. So we need to be very careful about this one. Okay, here we have the interventions by the nudge units. And we can see here that there is far less heterogeneity, far more homogeneity. Most of the results are here, just a little bit higher than zero. So they say nudges could have an effect, but very thin, very small. Okay, and we still have some very huge effects here. So I don't think there is a problem with these effects. My points, but I will not develop it here, is that we cannot call them nudges. Actually, it's too strong difference between the groups to say they are nudges. But probably that these effects are real. Okay, I don't think they are fraud or whatever. So probably a very small effect, but the question is it too small to be easily observable? This is one of the biggest meta-analysis of nudges from 2022, so it's very recent. The effectiveness of nudging, meta-analysis of choice architectures interventions. This is the claim of the authors. They say, drawing on more than 200 studies reporting over 450 effect sizes, more than 2 million participants. Our results show that choice architecture interventions over promotes behavior change with a small to medium effect size. So they say it works, and it works quite well. Okay. If we look at their forest plots. So a forest plot is a plot of all the studies with all the effects that goes from 0 here and could go to infinite. But basically nudges should be between 0 and 1. And so we have 0 here, which means no effects. And we can see, so I'm too little to show you, but on the top, like there are a few studies that are very high, and you will have a lot of studies that are higher than 0. Okay, so basically, we say we have found effects, but there are huge heterogeneities. We have effects here that are negative. We have a lot of effects that are null, and then we have a lot of studies that are positive. Here we have a funnel plot. The idea of a funnel plot is that we have here the standard error, which is an indicator of the precision. Here we have the effect size, and the precision means the lower you have a precision, the more the studies should be around the estimated effect size. So it means you have a pyramid. So if there are no publication biases, we should have all the studies inside the pyramid. The pyramid is here, and what we can see is that there are lots of studies here that are not captured in the pyramid. Why? Because this effect here is driven by all of these studies that are very high. I told you that we should not expect effect size of more than 1 for nudges, and here there are like effect size of 3. So what are the studies that drives the effect here? These studies, as Aaron Charlton says, they come from Brian Wansing papers. There are papers from a guy who wrote, and these papers should have been retracted, or at least should have not been taken into account in the meta-analysis. And all of these estimates is higher than 0 because of his studies. Then we have reanalysis of this study called no evidence for nudging after adjusting for publication bias. So we just take this forest plot here and we just take categories of them to look at how they have heterogeneity based on these categories here. And we have, okay, the categories are not really important here. We have 0 here, and you see that based on the categories, all of the categories are significant. Then for this paper, they take exactly the same figure here, and they just take what we call a robust Bayesian meta-analysis, which is the idea that we will not take into account these outliers here. And what they found is that if we don't take them into account, all the effects include 0. So basically, the meta-analysis says we have strong evidence for nudge effects, and this one says your evidence that nudges work comes from outliers, and if we delete these outliers, there are no effect at all, no matter the domain, no matter the category of nudges. Okay. Now, one question is, what is the quality of the nudges? If we do an experiment of nudges, how can we ensure that the design and the scenario and how people want to make the nudges appear, be effective, work? So this team of researchers, they looked at the pre-registrations made by nudge units. The pre-registration is a protocol we make before we make an experiment in which we say what are our hypotheses, what are the number of participants we want to have, what are our analysis we will make, how we will collect the data, etc., etc. So we explain everything we want to do in our experiment before we do the experiment. Okay, so they take it, and they so they use the data from the Lavina and Linus, which is the RTCs to scale, the first paper I showed you, and they looked at what are inside this pre-registration, and they I've seen that, for example, the main outcome, so the hypothesis, they are basically all reported. However, and this is very problematic, the sample size is never pre-registered. So if you have a very small effect, you should say, I need a lot of participants to make sure that I detect the effect. And since they don't do, maybe all of their positive findings are false positives, which means that they discovered an effect that maybe is not true because of the lack of participants. So this is a huge problem because we don't know if the real effects, if the positive effects are real. And we know that there are lots of different nudges that are tested and who doesn't work. Okay. Now, a paper that I made with my colleagues, and this one is a bit aside of what we just discussed before, is about the democratic problem with nudges. Researchers, basically, when they want to test nudges, they don't inform the participants. When they want to test if a white line will work, they will not say to the French Parisians, you will have a nudge with a line to drive your behavior to go to the train. They say that it's better for them because opaque, they use the term opaque nudges works better. However, in normal experiments, we inform participants. And in these kinds of experiments, we don't inform participants. So the question we wanted to answer is there evidence that shows that opaque nudges works better than transparent nudges? So we make a meta-analysis out of it. And the meta-analysis looks like that. So we again have a 0 here. And we have all of the studies around. And you can see that all of the studies basically are very close to 0. So basically no effects of transparency or opaqueness of nudges. So there's basically no differences between opaque and transparent nudges. If we look at the funnel plots here, we can see again 3 big outliers here and 1 big outlier here. But we have far more studies inside the pyramid than the previous one. So it's a little bit better, but not that much better. But basically, the effect is very close to 0. And this line here, which is called the Eiger regression test, it says that if probably we have outliers here, if this outlier doesn't exist, the effect should be here. So exactly 0. So it's like an estimate of the precision. I also recreated a table similar to the one from Mertens here, with here the confidence intervals to look at if the effects, depending on the type of experiment, the category and the domain, etc., can vary, and if in some categories we have positive effects. And if you look at the confidence intervals, they all include 0. So there are no effects in each categories. Okay. We have found an effect that is not displayed here that is quite interesting, but it is not significant, but it's very close to significance, is the effect of pre-registered experiments. Experiments that are pre-registered, they are more likely to be effective when they are transparent than not transparent. However, there are really few of them, and since the effect is very small, we haven't talked about that in the paper, but it could be interesting for the future. Okay, so no effect of transparency, which means that researchers maybe could reconsider their idea that nudges work better if they are opaque. And maybe they could say we shouldn't make it transparent by default, because transparency is important for citizens and for democracy. If you want to make claims from theories as libertarian paternalism, you should inform your citizens about what you want to do. Okay, this is a political oriented view, but it's important in our democracy to preserve this democracy. So just to make a conclusion on this part, we have to say that as any social sciences, behavioral economics is subject to false findings because of the lack of participants, because of the lack of pre-registration, because etc. Because also with problems around the analysis and the degree of freedom of researchers. And they're created by questionable practices and publication biases. Okay. It is then difficult to conclude for or against an ineffectiveness of nudges. We don't know. We have a lot of different researchers working on that, and we still don't really know if nudges work and what is the strength, what is the size of the effects formed by nudges. And as a meta-science group, our goal, my goal and goal of my colleagues, is to find ways to improve credibility in findings. Okay. So we come back to these slides and we will finish on these parts. So we have found that these arguments can be easily debunked, but then we can see that the fourth argument is very weak. Yeah. Is very weak. So nudges are political decisions. They need to be embedded in systematic policies and should not serve political agenda just because they sound evidence-based. They have to be rigorously tested. It is not enough to say we will use nudges because it's very nice to have nudges. We need to rigorously test it before we implement it to the overall country or across citizens. Instead of a paternalistic approach, some researchers are talking about the idea of boosting. Boosting is the idea to empower people to make better decisions by and for themselves. So the idea of nudging is we know better than you what is the correct decision, and we will nudge you toward the better decision. The idea of boosting is you have to understand by yourself what is the best option for you, and we will encourage you to boost you. We will boost you to the best option for you, not the one we think is the best. Okay. However, to be honest, I don't really see the difference between boosting and education. Education is like informing people so that they make a better informed choice and better informed decision. So it's not quite clear for me. It seems like education is something more timely consuming. You educate yourself through years and years, while boosting could be just interventions. Okay. Okay, so I finished on this first part, and now I will explain to you um, what is current in behavioral economics and what I think is one of the revolution we are evolving in. Just before that, but it is related. You have to know if you don't know yet that Kahneman passed away 2 weeks ago. I think you're surprised. 2 weeks ago, at the age of 90. But he helped this revolution too, because during the last 10 years, he moved away from bias to noise. And he has a book that is called Noise that explains his view on noise. The idea is while bias is about an average error in judgment, noise is about the variability in errors. How we can capture why in some contexts people make more errors than in other contexts. And this is what we call heterogeneity. Okay? This is what he calls noise, but I think they are very similar concepts. And you can see in very recent paper, this one is 2021, that we are talking about heterogeneity revolution. And behavioral science is unlikely to change the world without a heterogeneity revolution. Harnessing Heterogeneity in Behavioral Research Using Computational Social Sciences, 2023, a manifesto for applying behavioral science in 2023, in which the author says we need to go beyond a list of biases. He says the heterogeneity in behavioral science findings also means that our underlying theories need to improve. We are lacking good explanations for why findings vary so much. So this is just to say again what I just said before. We have an heterogeneity revolution coming in because we are more and more trying to understand in which context the cognitive bias works or don't work. Okay. Okay, few examples to show you my point. Here we have the anchoring effects. So it's a bias. The anchoring effect is a bias. And here, all of these researchers, they asked participants to, they show them a description that leads them to have an emotion. Okay, it could have been anger, disgust, etc. And they say, the question they ask is this emotion leading to more or less anchoring? And basically, if we have a good theory, one emotion should lead to more anchoring and another emotion should lead to less anchoring. But here, if we take this example here, Shen found that sadness leads to more anchoring with an effect size that is quite high. But then Bodenhausen and colleagues, they found that sadness goes to less anchoring with a positive effect size. So one study says one emotion leads to more anchoring, and the other says the same emotion goes to less anchoring. Why? Because there are heterogeneity in their scenarios. There is heterogeneity in their practice. Okay, so we need to understand what inside this heterogeneity leads to more or less anchoring. One example from one study of mine with Chandra Shekhar. Chandra Shekhar is the author for the conjunction bias with James and Linda. We work together on this study, which is quite complicated, and I will not explain to you exactly what is inside the scenarios, but basically what we wanted to test is the difference between the framing effect and the default effect on the job preference and on the medication preference. So the framing effect is, do you want to accept this new job or do you want to reject the new job? Okay. And the default condition is having one job that have more holidays and less pay, or having more pay and less holidays. So it's the default, basically. And for the medication is to reject or choose a new medication. Okay. What we thought is that the default and the framing should have additive effects. Okay, if we are in a good default mode, and if we are in a good framing, we should have the strongest effects. Okay. However, if you look at the interaction, they are not significant, and here they are not significant. So there are no additive effects. Why? The reason is that if you look at the statistics here, the statistics of framing is so high compared to the other, and here the statistic of framing is so high compared to the other that it leads the effect. So when we design nudge, thinking that, oh, maybe we could add several nudges in the same intervention because they would have additive effects, it is not the case because we have so much heterogeneities between the nudges that we cannot make such kind of inferences. More than that, here the default condition is very close to the framing. However, here it's very far away. So also here, we have a huge heterogeneity between the two scenarios. Okay. So let me explain another problem with heterogeneity. Here we have the same population across the four tables. So the author doesn't say that. I will just explain to you how it works. Basically, imagine that we want to make a nudge that works on smokers. We want people who smoke to smoke less. Okay. Then we can target heavy smokers. Here we would target heavy smokers. Or we could target all the smokers. Or we could target non-smokers. It's not intended, but maybe we decided to make our nudge in a place where there are not smokers at all. I don't know where there are no smokers at all, but okay, let's imagine. Or the whole population. Okay. But then if we study heavy smokers, we should have a very high mean. While if we study all smokers, we should have a mean that is far lower. Okay. And if we study non-smokers, the effect should be 0. And if we study the whole population, the mean should be very close to 0. So the target we have, the participants we want to have will hugely influence the means. Okay. And it is not controllable. I mean, it's very difficult to control who will be the persons who will come through the nudges. Okay. But we have to be aware of this heterogeneity because sometimes we will say, oh, this nudge works very well, but it works only on our targeted population, not on the whole population. However, if we want, for example, to lower smoking, we should not only target heavy smokers, we should target all the smokers. Okay. So this is just an example. Here, it's just a table. I will not go through the table. It's just to tell you that in this study, they explain a lot of different sources of heterogeneity and say that we know a bit what are all these sources and we can take them into account. However, for the moment, we don't take them as much as we could into account. So we need to do better. We have a few teams that works on heterogeneity, especially across countries or across cultures. One is what is called the Psychological Science Accelerator. The Psychological Science Accelerator is a multi-lab project in which lots of different labs around the world, they will work on the same topic. They will make exactly the same experiments. So we can see the variation across the laboratories. Okay. There are the behavioral change for good initiatives in the US, who is studying nudges or interventions to see if they have some effects that could be generalized to the whole US system. Okay. And also the character lab, who does exactly the same. They're just not in the same place. However, this is one problem I want to raise also, is that they will sunset their operations by the end of June 2024. And this psychological science accelerator is not funded at all. And the character lab and the behavioral change for good initiative, they are funded, but they have a fixed funded. They are not long-term funds. So this is some kind of problems we have with these initiatives, is that they cannot have long-term goals because they always need funds to be refunded years by years. So it's very difficult to test the effects of what they are testing across time. This is always a problem with these kinds of initiatives. Okay, another example from the Manifesto for Open Science. So there are lots of different criticisms of, sorry, a manifesto for behavior science, criticism about heterogeneity. And what I like about that is that they say the academics, the researchers, they are not the only responsible for this heterogeneity. The practitioners, the people who are testing nudges in real life, they are also responsible for this heterogeneity. The funders are also responsible because they don't uh, pay enough, or they don't want to pay to test it rigorously, to make, for example, two different experiments to test if there are variations between the two, and also the client. So there are lots of different interesting criticism and arguments in this paper that is quite interesting. Okay, so there are criticism of neoclassical theories on what is rationality. So this is the bias. However, if we study decision-making based on rationality, we see that people make several errors. This is true, we make errors in our judgments, and sometimes we regret them. Only a few have been found as systematic, and systematic errors are cognitive biases. Most of them are noise. It's just like we are not optimal because we have few noise, because we are influenced by our environment, or we are, and etc. Because of the complexity of human beings, but also because of the context dependency. If we have a scenario, we need to have the full information of the scenario. If the context varies, maybe our decision will vary as well. And because of the difference between experimental method used, between a method in which we can learn and we can practice, or a method in which we only have a description and we will have to make a decision based on the description. And it leads to several differences. So we came from the idea in behavioral economics, we came from the idea that we are all victims of our biases because we are irrational, to an idea today that we have developed a theory of rationality and irrationality based on the heuristic and bias program. And we are trying to figure out how well this theory applies in real life situations. So we have to be humble about our theory and say we cannot generalize it too much. We need to test it rigorously in real life situations. Are we intuitive statisticians, or are we irrational beings? It depends on the choice, the context of the choice, and the way we measure the choice. This is the conclusion. So I have a lot of references here. So again, if you want to see the slides, it will be on the YouTube videos, under the YouTube videos, so we can